Hello everyone. I am Dr. N. Mamatha, working as Assistant Professor in Department of Chemistry, VNR VJEC, Hyderabad. Today, we are discussing the course Introduction to Climate Change relating Sustainable Development Goal 13, the most critical issue. We look at the why and how behind the global climate crisis. Why now? Because we are living in a period of climate polycrisis. According to recent data, 2024 has set new records as the warmest year globally. In India, we have seen a temperature anomaly of 0.65 degrees centigrades. This is not just a number, it translates to the heat waves which you have experienced this summer. From a professional standpoint, the industry is changing. It is designed as a foundational bridge between environmental science, policy, and engineering. The journey toward a net zero world depends heavily on engineers, whose technical skills enable advancements in clean energy, AI based climate modeling, and sustainable infrastructure. Engineers' contributions are crucial in addressing climate change and ensuring environmental resilience. In our course contents, we are going to witness all the 5 units. Unit 1 is to introduce the concept of climate change and its historical context. Second objective of Unit 2, Impact and Vulnerabilities, is to analyze the ecological consequences of climate change impacts. Unit 3, Mitigation and Adaptation Strategies. Third objective is to explore strategies for adaptation and mitigation of climate change. Unit 4, Climate Models and Projections. Fourth objective is to understand the global climate change models and predictions. Unit 5, Climate Policy and Governance. Final objective is to examine international and national climate policies. The climate change pillars. The course is structured to provide a 360 degrees overview of the crisis. It begins with the foundation, understanding the chemical and physical drivers of our atmosphere. Next, we move on to ecology, looking at how systemic shifts impact global resources. The focus on resilience. How do we build systems that survive a changing climate? And finally, governance. As India takes a leadership role in G20 and United Nations Framework Conventions on Climate Change, understanding the rules of game in international climate policy is essential for anyone looking to work in global industry or research. So, in Unit 1, Basics of Climate Change, in Module 1, we strip away the myths. We look at the data-driven science of natural versus anthropogenic drivers. We analyze how greenhouse gases like carbon dioxide and methane function at a molecular level to trap heat. Notice the image of the Himalayan glaciers. This is our water tower and it is melting. We will analyze how aerosols and land use changes in India are specifically affecting our monsoon patterns. And we also look at the human footprint. We explore how heat generated by cities and aerosols from industries impact the air we breathe every day. Understanding this climate chemistry is the first step in designing the mitigation technologies for tomorrow. Why India's heat is getting harsher in 2026? Early heat waves, below normal rainfall, El Nino risk, and rising human cost. What is El Nino? El Nino and La Nina are significant ocean atmosphere phenomena caused by changes in ocean currents in the Pacific Ocean. They result in global weather anomalies such as droughts, floods, and storms, affecting ecosystems, agriculture, and economies worldwide. Climate change can intensify these events, leading to more unpredictable weather. India's real-time data analysis. Let's look at the evidence. According to the India Meteorological Department 2024 reports, we are seeing higher than average monsoons, 108% in some regions, but devastating cloudburst patterns. These patterns can lead to lot of impacts and vulnerabilities. However, there is a reason for optimism. India's non-fossil fuel capacity has crossed 52% mark. This is not just a win for the environment, it is a massive industrial shift. This slide shows that the transition is happening now and it requires a workforce that understands both the data and the science behind these numbers. Unit 2, Impacts and Vulnerabilities. To understand the stakes, we examine the real world case studies like the South Lonak Lake breach in Sikkim. This was a glacial lake flood creating major disaster. When the lake breached, it is not only caused flood but also destroyed a 1250 megawatts hydroelectric dam. It shows that our infrastructure designed using historical weather data is no longer safe. We must learn to design for extreme climates. For instance, few case studies like Jammu Kashmir floods, Wayanad lake slides in Kerala. So in this course, we analyze these case studies to ensure our future builders. In this course, we analyze these case studies to ensure our future engineers build more climate resilient infrastructure. Unit 3, Mitigation and Adaptation Strategies. The heart of the course lies in the solutions. In Unit 3, we explore the green industrial revolution towards renewable resources and resilient infrastructure. Mitigation and clean tech. In this mitigation and clean tech, our first pillar, the science and the technology of stopping carbon emissions at the source. The renewables deep analysis of global transition, the mechanics, scalability, and economic limitations of renewable sources. Energy efficiency. It is the fastest, most effective energy demand, the way we flatten the global energy demand curve. Carbon capture and storage. For heavy industries like cement, steel, and chemical manufacturing, which are the major sources of carbon dioxide, engineers have to design the energy efficient and carbon capture storage systems directly from the point sources. Adaptation, resilient infrastructure, and planning. Technology is only half the battle. Even if we stop all global emissions tonight, a certain degree of warming and climate volatility is already locked into Earth's system. This brings us to our second pillar, that is adaptation. We must learn to adapt. The resilient infrastructure designed by the engineers will tell us how do we mitigate the flood defense barriers. This segment will guide us how to design resilient infrastructure and smart cities that can withstand extreme weather events, rising sea levels, and also changing precipitation patterns. Climate smart agriculture. The climate smart agriculture includes using data driven farming, drones, and crop genetics to maximize flood yields while preserving soil health and reducing water consumption. The third initiative can be the international governance, policy and frameworks. Finally, governance. Brilliant engineering is useless without systemic coordination. This concept traces the evolution of international policy from the historic foundations of Kyoto Protocol to the modern compliance mandates of the Paris Agreement. Unit 4, Climate Models and Projections. We also look at the climate tech. How can AI predict a cyclone 48 hours earlier? How can IoT sensors optimize irrigation to save 30% more water? We bridge the gap between environmental science and digital innovation, showing how the synergy between code and hardware can literally save our planet. Climate change modeling basics to impacts. Climate modeling helps to future climate changes using scientific data and computer simulations. Historical climate data help us understanding past, present, and future trends. General circulation models and representative concentration pathways are used to study different emission scenarios and climate projections. Regional climate models provide local predictions, while uncertainty analysis improves decision making. These models help assess impacts on ecosystem and society for the economy. AI and IoT for climate modeling. AI and IoT improve climate modeling through real-time data collection and advanced data analysis. IoT sensors monitor weather, oceans, and air quality, while AI identifies patterns and improves prediction accuracy. These technologies support early warning systems, disaster management, and sustainable planning for climate resilience. Climate policies and governance is the last unit. Climate policies support sustainable development by promoting clean energy, environmental protection, and economic stability. Effective governance and international cooperation are essential for building a sustainable future. As a part of this course, these countries work together to address climate change through international policies, agreements, and financial cooperation through United Nations Framework Conventions on Climate Change. Agreements like the Kyoto Protocol and Paris Agreement encourage nations to reduce greenhouse gas emissions and strengthen climate resilience. India's long term commitments. So, our country, India has set a goal of 2070, which is net zero target, the bold target of net zero. To achieve this, the government has launched the National Climate Action Plan on climate change. The core missions of this policy are National Solar Missions, focusing the area of solar energy deployment, which has achieved 50% target early 5 years. National Water Mission, water conservation and efficiency, has rejuvenated rivers and watershed development. Himalayan ecosystem, the glaciers that are melting, biodiversity that is monitored, and 195 high-risk lakes and are under monitoring. The final mission what we have from our country is Green India Mission, forest cover and carbon sinks is the focus area. Ek Ped Maa Ke Naam. This is the mass movement what we have. We are the first generation to feel the impact of climate change and the last generation that can be done. So this course is not just a subject, it is the operating system of the future world. Let's build a climate resilient future together. Thank you. In conclusion, we also look at how and why this course has been introduced into our college, and we'll be discussing about the impacts and the vulnerabilities of the course. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.